Good day, everyone. In today's session, I'll be covering Unit Standard 14921, and the title of this Unit Standard is Describe the Types of Computer Systems and Associated Hardware Configurations. So, let's look into the second slide. The outcomes of this unit standard, people credited with this unit standard will be able to describe past, present, and future computer hardware configurations. This is for session 1. This is what we're going to cover in today's session, and also describe categories of computer system applications. So this unit standard consists only of 2 sessions. So for today, I'll only cover session 1, which is describe past, present, and future computer hardware configurations. So let's look into session 1. Describe past, present, and future computer hardware configurations. We've got computer configs and hardware. So let's look at what is a configuration. What do they mean by the term of configuration? So a configuration is an arrangement of functional units according to their nature, number, and chief characteristics. What do they mean by this? So it depends in terms of what the configuration is aligned to. If the config is aligned to a software, the arrangement in terms of how you go about uh, making those arrangements to make that software work, it will depend on the function of what are you basically configuring about. So if it's a hardware, it will depend in terms of assembling all of your peripherals or components in order for the system unit to work. The system unit, meaning the computer, which includes your desktop, your PC. So it's just an arrangement of components that you gather, you assemble in order for your system to work. So in terms of a software point of perspective, we look at the units according to their nature and their chief characteristics. So now we're trying to configure a certain application based on its function. So I'm arranging certain functional units where I need to click there, drag and drop, fix certain things, configure based on the standard by default. So it depends according to its nature. Also, configuration pertains to the choice of hardware, software, firmware, and documentation. For documentation, in basic terms, what they normally do, they just uh, give out documentation in order for you how to go about. I will show you just now shortly. So I just want to show you a documentation in terms of how you go about in terms of configuring a software. So I've managed to search setting up a wireless network in Windows. They'll just give a brief description in terms of what type of internet you are connected to, whether it's a wireless or Ethernet cables. So these are your documentation, which they tell you in terms of where to start. You select a start, go to device manager and then set your device manager, expand the network adapters, look for a LAN adapter that might have wireless in the name. So this is more of your config. Once you do such things, you follow these kind of steps, you configuring the software, which is your operating system. But in this instance, you wanna set up a wireless network in Windows. And also uh, we have something similar in terms of guide to network and sharing center for Windows 7, 8, and 10. So they'll just tell you briefly in terms of what you should do. So you'll just go to your start button, just press for network, and just follow these kind of steps using a Windows 7. And by so doing this, you are configuring. So this is what they mean in terms of pertains to the choice of data or the arrangement of functional units according to their nature. And also configurations affect the system function and performance. So if we can go back to this, once we go about in terms of doing such configurations, like for instance, let's try to go to our control panel, and also what needs to be done, we need to go to network and sharing. And so this is just my public network that I'm using, which is my Wi-Fi. So if, let's say for instance, I were to do, let's say, based on what we were given from, okay, we want to set up a network. Okay, they don't say much. Okay, we don't, let's say maybe there's certain advanced. Okay, let's go to, I think this would be much more relevant to what we want to try to do. So let's say for instance, there are certain things that we want to do. So go to our Wi-Fi, go to check advanced sharing options. So anything that I were to do in terms of these configs, automatically it will affect the system. So let's say for instance, for network discovery, so when network discovery is on, this computer can see other network computers and devices and is visible to other network computers. So if I can turn this on and save the changes automatically it will affect the system. So I won't be able to see other networks that I'm connected to this public network. So if there's any network node that is connected to this Wi-Fi, I won't be able to detect because of I've turned on this kind of config. So that's what they mean in terms of configuration. It affects system functions and performance. And also hardware configuration, it refers to the system resources settings that are assigned to a specific device. It depends, or it varies in terms of the settings that are adhered to the hardware configuration. So it depends, it varies. So if you want, for example, you have your plug and play devices, automatically it comes with its configurations. And some devices, it will require you to, maybe update certain, like for instance, the mouse that I'm using, it's a plug and play. So obviously some you should update maybe the driver, and also maybe it might malfunction. So you can just update the drivers and check if maybe there are certain drivers, maybe these are updated and stuff. So it depends, it varies uh, based on the setting that you are using. Network adapters also, it depends on the unique, but these are just much more in depth, but just a foundational level in terms of understanding uh, the hardware configurations. It depends in terms of the resource settings that are assigned to that specific device. So some hardware would require you to follow a documentation where you just click and follow the certain configurations that are by default that you should use. And also, on to the next slide, we look at the all hardware devices have configuration settings that can impact the overall performance and system function. This is true. So it can be in a good way and in a bad way. So it can impact in terms of its functions in terms of what is it intended to do, that particular hardware. So some might malfunction if maybe, let's say, you try to install a certain external, maybe peripheral and it malfunctions, it doesn't intend to do its function. So it will depend the impact whether it's positive or negative. And also some devices that can be adjusted might include the accessible memory connected to devices, disk drivers, modems, serial ports, and some power management features. It will depend also in terms of the devices that you are using, and it could be adjusted based on what you as an end user would, your preference in terms of the types of settings you want to use. And also we have how do computer hardware and software hardware work together. So computer hardware and software are two opposite components that make up a computer system. So software needs a hardware config to run on it, and also understanding your software and hardware needs an essential to guide the most out of your technological experience. So these two, a hardware and a software, they are components that make a computer system. So we need a hardware, we need a software installed in a hardware so that it can operate. Software needs hardware config to run on it. What do they mean by that? Certain hardware configuration by default, it depends on the kind of software you want to install in a certain hardware that you are running. For instance, I'll be having an external hard drive, and in this external hard drive I would like to install an OS. So an OS will require a certain amount of space that is needed for it to run. Let's say for instance, if you are running Windows 10, it might require maybe to run about 60 gig for it, and it will specify in terms of in that 60 gig you have to partition certain parts. So that's what they made in terms of the software. It needs a hardware configuration to run on it. And also what is the difference between a standalone computer and a network computer? So we need to differentiate, move by steps in terms of now understanding the hardwares that we have, and also moving in terms of a network computer. So now we have a basic understanding in terms of within a computer system, we have inside it we have a device, we have a hardware and a software which makes a computer system, and these are opposite and they work hand in hand for it to for a computer system to function. So now we are moving from that in terms of now understanding a computer which is being referred as a standalone or a network computer. So let's look in terms of a standalone computer. So a standalone computer is just a self-sufficient system. There is no connection to any other computer, meaning the devices that you use at home, those are your self-sufficient systems. So there is no connection to any other computer. I'll just repeat this, to any other computer. So for various tasks such as writing a memo or creating a spreadsheet, the software application installed on the standalone hard drive are used. So all those software that are installed in your hard drive are used in that standalone computer. Also, a standalone may have a printer, a scanner, or an external hard drive attached to its CPU to use to print or scan a document or implement a backup system. So this is just your basic standalone computer where you can just connect it to a printer where you just need to print certain documents, or if maybe you've got your external hard drive where you save personal documents within it. So it depends. Maybe you want to do backup system, that's more likely your standalone computer. The ones that you use at home, the ones that you do assessments, we refer those as your standalone computers. So on slide 8, the advantages of a standalone computer system is that it is more secure than computers that are part of a network, because it's much more safer if you can think about it. Having a standalone computer, you're not exposed to security threats, because within a network computer there are more chances that that network can be exposed to threats, meaning your viruses, your malwares, and so forth. But with standalone, having your own softwares, it's likely that you might encounter issues such as security breaches and threats. Also, a standalone lessons and possibility eliminates the concern that hackers, spyware, or viruses can compromise confidential information by accessing it. It's impossible because now, most of the time, you've got your systems that are in place. More precisely, your softwares, your antivirus software. So it's not easy for security threats to breach your standalone because of it's secured unless maybe your computer is not updated like your OS, and also you don't have maybe your antivirus, and also you share files, or you share maybe external hard drives, or maybe your USB, you share around with other with maybe your friends and so forth, and maybe it might contain maybe virus. That's when you can contain maybe threats within your system. But over the network it's impossible because of, and if you have in step in within your system, you have steps like installing your antivirus, and also your OS are updated, all that, which is a package. You have that within your system, then you are less at the risk in terms of being exposed to threats. So let's look at a network computer on slide 9. A network computer is just a computer that connects to one or more computers for the main purpose of communicating. So in this instance, we have a peer-to-peer kind of setup where Windows have this. I'll just refer to Windows because that's what I've been exposed to. These other OS operating system products like your Ubuntu, Linux, and Mac. I've never worked with them, so I wouldn't comment or comment on them in terms of having a peer-to-peer. I don't know its kind of settings, but if it does have such settings, it's much more easier, because you just follow the steps. So a peer-to-peer kind of network, it's where one computer can share all the computers, all the network computers are connected amongst them. So you can just share files within it. So we'll just look into that peer-to-peer in the later part of this session. Also, the advantage of a network computer is that it shares resources such as software applications, printers, disk drives, and data files with other network computers. A disadvantages of being a network computer is the real possibility of becoming a victim of computer hackers, viruses, and spyware. Um, it's possible. Like we have like your DOS attack, denial of service attacks, that can be a threat to your network. And also it depends, because of now with these network computer, if one user may let's say for instance we're in an office, and one user comes with this personal USB, and that USB contains virus, and now he plugs it and saves certain files within where we normally have an access, where we just save our documents. And if the virus can just can save, maybe if maybe the files that this user has, and saves it in that restricted folder, so now everyone will be succumbed to the virus within the environment. So those are just the possibilities of becoming a victim in terms of the viruses and spyware. And also, with the possibility of the real threat, it would be in your best interest to install a virus protection and malware software. So these are just um, one of the steps that you need to follow in terms of installing a virus protection, like your antivirus, where it can protect your uh, systems within this network. So we have managed to cover the types of of systems or of computers that you find in terms of a network computer and a standalone. So now we're going to move in terms of having a mid-range computer within our network. So let's move on to slide 10. Slide 10, mid-range computers or mid-range systems. So a mid-range computer is often used as a server, which means it provides storage, processing power, and other functions to users connected to it by a network. So these users are called clients, hence the term client-server network. So a mid-range computer contains hardware that allows for advanced networking and ports for connecting to more business-oriented peripherals such as large-scale data storage devices. Mid-range servers run on an IBM One operating systems. From a hardware perspective, a mid-range server is a single standalone system. So uh, this it's precisely something similar to having on our project. On our project, let's say for instance, we assume that we have installed a mid-range server, which is a client server where within our environment users may request certain files within this mid-range server. So within this mid-range server, it depends or it varies in terms of the services that are installed in that server. So we may assume that this one of these servers within our DMZ are your mid-range servers. So for, let's say for instance, your database, this is our database, your DBMS, it's one of the mid-range server. So within it we know that we save uh, data or information within our LAN. All of our internal network information is being saved from there. So this is much more of your mid-range server. It's your client server. So each if a certain user would request certain information within this, he would log a call, and the process would fall in terms of allowing that certain user to access that certain information. So on slide 11, I've illustrated the type of a mid-range server. This is just a server box. It depends on the architecture, the design of it. In most cases, it may be similar to your desktop, but the design of it might be different compared to your normal desktop. So as you can see on the image that I've extracted, it's quite different. And how they've designed you can just tell by just seeing it that this it's either your supercomputer or a mid-range server, a mid-range system or computer. And also on slide 12, I've just managed to extract another image which further illustrates a mid-range computer. Depends on the environment that you are in. In most cases, uh, depending on the number of users that we have, they might go uh, with the bigger box, as you can see on the image that I've extracted. So that's more of your mid-range server. So now we'll move on to another term, which is a client server on slide 13. And on client server, so the client server model is a network architecture that describes how servers share resources and interact with network devices. So a large number of personal computers communicate with shared servers on a local on a LAN. So the client server model describes how network devices like workstations, laptops, and Internet of Things devices known as clients make requests to network machines or software capable of completing the request known as servers. So in this instance, it describes how servers share resources and interact with network devices. So a large number of personal computers communicate with shared servers on the LAN. Um, Within that LAN, that the devices includes your workstations, laptops, your Internet of Things devices known as clients, make requests to the network machines or software capable of completing the request. Also, on to slide 14, we've got the components of the client server model. So in terms of the examples, or from client's perspective, we've got your workstations. Your workstation can be a client which requests a certain files within the database server. We've got desktops, laptops, tablets, smartphone, Internet of Things devices. Within the server's perspective range, we've got your database server, DNS, web application, file server, proxy server, virtual machine. So I just want to show you something on to uh, the Cisco Packet Tracer onto the servers that we have. It contains services that you may have, like for instance, if you go to your server and go to services, you can check the services that comes within that server. You can choose in terms of which services would you require that particular server be. So within this server, we would say this will be our email server we need to set up, and whether it uses an SMTP service port, or it uses a post office protocol 3 service. So it depends whether maybe you want it to be your FTP server, your DNS, your DHCP version 6, your DHCP, your HTTP, more likely like your proxy server. So it depends in terms of the services. So that's what they mean in terms of the examples. So there's quite a lot. And the networking devices examples, we have got your hub, your bridge, your switch, your router, your gateway, and modem. So there's quite a lot. So let's continue further with slide 15. On slide 15, what are the components of a client server model? We've got your clients. Your network clients are diverse, it's different. There's quite a lot, as you can see from our slide 14. Client, there's quite a lot. We've got workstations, so these are diverse. We're not specific. It can be your desktop, can be your laptop, it can be your workstation, and all have got particular functions and limitations. Also, your network clients are diverse devices and operating system types. Depends whether you're using Windows, Linux, Ubuntu, Mac, and so forth. Administrators have the added responsibility of ensuring compatibility. So you guys are responsible in terms of all these workstations are compatible within the network that you are using, or all the network devices can communicate within that network. Also, you've got your servers. So the machines delivering IT resources to clients are the physical, virtual, and cloud-based servers housed in modern data centers. So servers are the central authority for several essential digital processes that enterprise organizations rely on. So we know that our servers are more of delivering IT resources to clients. So resources to clients, it's more based on I request certain resources on the DBMS. I request certain files. I want to access certain tables within the DBMS. Those kind of things. And if you're using a web server, I need to access a certain website. So it's more of delivering IT resources. I need to go from point A to point B. Depending on that particular server, it will deliver that resource. And on to slide 16, we've got networking devices, or the physical or the wireless networking devices like your hubs, switches, and routers to connect servers, clients, and resources. With the connection between clients and servers are established, administrators can configure how client devices make requests and designate servers to complete a specific task. So it depends in terms of how you configure based on what you want. Like for instance, I think for the past week we have been on to our LAN where we would like it to configure based on the firewall that we have managed to implement. So in that type of scenario, we need to configure in terms of how these resources would communicate amongst each other, and how would the flow of communication, meaning our information, would flow from one point to another, from internal to external, and so forth. So now, after going through these unit standard, we would now know what we would need within our environment. So we would know that we need a web server client server within our client. We need a DNS server within our environment. So those are important items. But based on what we have went through onto these unit standard, more especially this one, will give us a clue in terms of what do we have to include within our LAN or our WAN diagram. So on slide 17, how does the client server model work? So the client submits a request through a network enabled device. The network server receives and proceeds processes the request, and lastly the server delivers a response to the client. So this is just a three-way uh, simple way in terms of how the client server model works. And also let's look at the client server model examples on slide 18. uh More, let's look at how to, like, facilitating email. I think I've covered this, but let's go in depth. For communication, it's essential to enterprise organizations. The hosting of email communication for an organization or a network by a specific server has been the long time industry choice to control particular email accounts and activity. Through protocols like your IMAP, POP3, and SMTP, administrators can establish a system that facilitates, secures, and maintains email communication. It depends in terms of these protocols that are used. So using their in terms of depends in terms of how you configure them. Remember when we configured in terms of when you use SMTP, I think it was SMTP or IMAP. When you send through port 25, but when you receive it's through 995. So you have to configure that onto your Outlook software application. So that's what they mean in terms of you need to establish a system that facilitates, meaning how you configure these protocols. And also when using their email accounts, staff are the clients, meaning your employees are the clients, making requests to send emails, upload attachments, and store contacts to an email server. So that's more of how you configure, and automatically these configurations will allow your employees to perform their day-to-day functions. uh, Continue further on to slide 19, we've got accessing web content. So when a web client wants to access a specific website, they enter the URL, and the browser requests an IP address from the domain name system, and the DNS server assigns the user an IP address for identification and delivery of results. The end user is the client presented with digital content. The DNS server and web server establish and facilitate the connection to a database hosting the web content. So this is just a in-depth analysis of how, when a certain user wants to access a certain website, so they'll enter the URL as per normal. This is the URL. um, this is more of your URL if you want to go to stat SA, for example. So depending on, because of now I'm using my personal router, automatically within its configuration, it uses the same DNS. It uses the same DNS server, which is the same default gateway router's name. So with this instance, it's much more easier to access website. So I'm more of your client, and I if I request, the router itself would allocate me to that certain websites. So that's more in a nutshell, but based on what I'm using. But in an enterprise environment, it's quite different. There are certain technologies that are installed in order to facilitate these kind of requests, to clients. And also on slide 20, we're looking at the advantages and the disadvantages of the client server model. So its advantages now: central access and control of data, efficient, scalable, and organized system, load balancing for optimal performance. It means in terms of there's no redundancy, so it balances off. I think we have done that on our architecture, where we had two switches within our environment. That's more of load balancing, but in a logical format, how they do configurations, there are options within the, depending on the product or the kind of switch that you are using. You find that there's options where there's load balancing for optimal performances. In most instances, some expert within the networking would refer our architecture as the redundancy and data recovery, because of you are having two switches, where we can just have a much modified maybe switch where it can have this option for load balancing. We can just enhance it within, in terms of configs within our device. Also, we've got network of devices, interconnected network of devices. Those are much more advantage of a client server. Its disadvantages: less control of some network devices, upfront cost and implementation, technical expertise for ongoing maintenance, server at risk for DOS attacks, denial of service attacks, clients are attack vendors when breached. So as I've stated previously, in terms of your less control of sub network devices, there's no control. Like within this client server, everyone can just access anything. There's no much control. And with upfront cost and implementation, there's so much that needs to be maintained within the network itself. We need technical expertise. You guys, you need to be on to the in terms of expertise, consulting in terms of what needs to happen in terms of maintenance. Some of the servers may be down. Client server model is much, it's quite much expensive, and it's at risk in terms of the denial of service attacks. It will depend in terms of how your security structure is structured within your environment. Let's look at the one item that I wanted us to cover, and also we'll just do a practical exercise with it. It's more of your peer-to-peer network. So let's look at the peer-to-peer network versus client server. So through the client server framework is most the popular distributed architecture. The most common alternative mentioned is the peer-to-peer networks. Unlike the client server architecture, which offers a centralized flow from an organization server to staff, stakeholders, and clients, a peer-to-peer, let me highlight this, highlight in red. So a peer-to-peer network is a decentralized a peer-to-peer network is a decentralized and network devices don't align with a specific dedicated server. Instead, peer-to-peer networks include network devices known as nodes that submit and receive and service requests between each other. So in this instance, it's much more easier. This is what I wanted us to do, just a practical exercise in order for us to connect the devices within a network. So this is much more basic, simple stuff. We refer that as peer-to-peer compared to a client server. So peer-to-peer, these nodes are connected to each other. Nodes meaning your printer, exclude switch and router. No, exclude switch in this instance. So that we might be connected to a wireless router, and all these workstations are connected amongst each other. So we've got your laptops, your printers, and with these devices they communicate amongst each other there's certain uh, um if there's certain information, it's much more easier to access. Let's say we've got five PCs which are connected to each other, and PC1 saves certain documents, PC2, and so forth and so forth. So if I request certain information or documents, I will just go to the network that I'm connected to, and let me show you. I'll just go to the network that I'm connected to. Automatically it will just display all the networks that are connected within this network, and I'll just go through that particular device and access those files that are saved. So uh, that's more of your peer-to-peer network. And also on slide 22, because of P2P networks like blockchains work in a distributed fashion, connectivity is critical to operations. So, relative to traditional networks, nodes tend to be more varied and share less data across the network. The client server model is more expensive to set up and maintain, but the reliability and scalability of the centralized framework consistently outweigh the downfalls of peer to peer frameworks. It's much more simple and straight to the point. With peer to peer, it's more of your small network that you have, and you don't you it's based on what you have, the budget in terms of having a much more uh bigger uh architecture, or bigger enterprise. Maybe your budget, it's you don't mind having, your larger networks. It depends. So you will go more of a budget that you can maintain. So in most instances you may find yourself maybe consulting for a organization which they use a peer-to-peer. In most cases there's no much in terms of how you go about in terms of maintaining that and configuring certain commands within your network. It doesn't require much. But with client server, there's so much in place, and there's so much network devices that are installed within the network. So also on slide 23, we'll look at what is the computer configuration. So a computer configuration is termed complete when all the major functional parts, which include hardware and software parts of it, get assembled. So proper assembling plays a role in performance of the computer. So the performance and productivity of a computer completely depends on how smart is your choice of accessories. So every time when you start your PC, first you have to configure it with all the basic setups. Basic setups needed for assembling a PC includes the main memory, hard disk drive, card reader, CPU. In most cases you don't have to configure, because most settings configs are by default. So unless maybe one of your components are malfunctioning and you are required to configure or change your settings, that's when you'll change. But in most cases these configs are by default, so you don't have to configure anything. Even if you start connecting maybe your PC or owning your PC, by default these components are set, configure when you configure them are by default, so there's no need for you to change settings and so forth. Also, we need to look in terms of a single user and a multi-user. So we'll start with the multi-user. So a multi-user is a term that defines an operating system or an application software that allows access by multiple users of a computer. So a multi-user operating system allows many different users to take advantage of computer resources simultaneously. So these kind of operating systems or application, that's more of your server. It depends on the server that you are using. In most cases, these servers allows simultaneous users to take advantage or use different functions within that particular operating systems. So I can log on into the server remotely. Also, you can log in that particular server remotely. So that is more of your multi-user OS or multi-user application software. So the operating system must make sure that the requirements of the various users are balanced and that each of the programs they are using has sufficient and separate resources, so that a problem with one user doesn't affect the entire community of users. In most cases, what do they refer to this is that you may find some of maybe the configs of a certain user. Maybe when he tries to access, his credentials are only read and write, so that the permissions given to that particular user are not affected by others who can modify, read and write. So that's what they refer to in terms of various users have to be balanced, and depending on the resources that they use, it does not have a problem with another user or does not affect the entire community of users. So let's move on to a single user. So a single user, as the name implies, this operating system is designed to manage the computer so that one user can effectively do one thing at a time. So that's more of your Palm OS operating system for Palm handheld computers, which is a good example for modern single user or single task operating system. As the word suggests, the single user, only that particular user can operate that application at that time. It's not multi-user. Also, multi-user, this is the type of operating system most people use on their desktop and laptop computers today. So Microsoft Windows and Apple Mac OS platforms are both examples of operating systems that will let a single user have several programs in operation at the same time. So like what you are using, the operating system that you're using, does not allow two people to access it, even if maybe you can use other applications like your team viewer, what's that other application where I can just remotely access maybe your OS if maybe you have issues. Always when you utilize those kind of application, it allows only as one user to operate. You can't operate whilst the other user has been RDP'd on your workstation. For example, it's entirely possible for a Windows user to be writing a note in a word processor while downloading a file from the internet, while printing the text of an email message. It depends in terms of the processor that you are using. So if you are using a single processor, obviously the tasks that are generated, it will take one task at a time. So it depends, because now things have been modified. You can do other task, simultaneous task, depending on the processing that you are using. Let's move on to differentiating between a single processor and a multi-processor. So a single processor system contains only one processor, so only one process can be executed at a time. Then the process is selected from the ready queue. So most general purpose computers contain the single processor as they are commonly in use. So I'm thinking the devices that you are using has a single processor, hence why when you try to download applications, is it applications, software application that requires you to do multi processing task at simultaneously, hence why it crashes, it affects the hardware and stuff. So some of maybe your systems may malfunction, may not respond when you do certain task within it. So I'm thinking maybe I'm not quite sure of the spec of your laptops that you are using, but I'm thinking of the you are using a single processor. Also, a multiprocessor system has more than one both types of system and can have more than one core per processor. Also, a multiprocessor is a single computer component with two or more independent actual central processing units called cores. Like what I'm using a dual core i3. So which are the units that read and execute program instructions. So I can just uh, do simultaneous task. My processor can just do three or more tasks at once. So the instructions are ordinary CPU instructions such as add, move, data, branch, but the multiple cores can run multiple instructions at the same time, increasing the overall speed for programs assembling to parallel computing. Yeah, so it depends in terms of the processing that you are using. So with the one that I'm using, I'm able to do multiple, instructions. I can open up a Word document. I can also open up your Cisco Packet Tracer, and I can also type in. I can open this application, the Upper Power. Is it the Upper Power application? Where I can do videos. So simultaneously, I can open up three different applications and do tasks within it. So if I do features, certain features within these applications, it will uh, give instruction to the CPU, and the CPU will just work as fine as is. So I won't have any issues compared to the devices that you are using. You may experience issues, and then the next day you might find that you need some of maybe your hardware is not responding. You have to change maybe a hardware component within your or your hardware might be affected. So let's move on to managing multiple environment configurations. So this is more of we always did this. I remember when I've given out examples in terms of whenever we do testings on our environments, we have to have a separate environment, and that certain environment has to be the same configs that you are applying on the environment that you are working on. So this is likely more of explaining in depth in terms of managing multiple environment configuration, and also they provide examples based on how to save and how to run certain files. So when developing an application, you'll mostly likely have a number of environments that your code will need to run in. So for example, you may have a development environment, a testing environment, and a live production environment. So you'll be having a, a testing environment and a live production environment. So if each member of your team is developing an application on their own machine, then they may have each have their own specific environment requirements. So the requirements should be the same, because of now you can't have configs being done on a testing machines, whereas it's far different compared to the live production environment, because it won't make sense. So the environment requirements have to be the same. So let's look at the last slide. No, slide 30. Your application will have a standard set of environment properties that differ within each environment. So this may include the data source details, file paths, and domain names. You may also have a set of configuration properties that should be the same across all of your environments. That's what I was referring to. So there should be a set of configuration properties that should be the same across all your environments, such as the company name or application constants. So this is just another example that I've provided. But in the in the project that we are working on, obviously when you test, you can't test different configs on the example, on the example on a testing environment, and also have a different set of configs on a live production environment. It does not make sense, because when you try to run the testing, what you have tested on your testing environment, it might not work because of the configs are not the same. So that's what they're trying to emphasize that on slide 30. So moving on to slide 31, this is much more in depth in terms of the environments you need following a variable properties defined. So the asset path, this is much more of what you have on your environment. So the asset path, the documents path, the data source name, and so forth. And assume that the common properties for environment are, so these would be much more of your on your live production environment, and this would be much more of your testing environment, and you want to test certain these configs on your testing environment, and you want to integrate this on your live environment. So this is much more an in-depth analysis where they just go in depth and show you in terms of certain configs that might be the same and some might not be because of based on what you are trying to test. So that's it in terms of session 1 for Uni Standard 14921. So when we meet, when we have our sessions, I think in the next couple of days, I would like us to have this assessment to do. We'll just have to create a peer-to-peer network. So we'll create a peer-to-peer network. Also, I've just shared communication to everyone. So I'm hoping I'll receive a positive response to you guys where we'll just go through or create or just meet and create this peer-to-peer network. So far today we've managed to cover describing the past, present, and future computer hardware configurations. We've covered that. Tomorrow on our next session we'll just continue off with the categories of computer system applications. So that's it in terms of today's sessions. We'll see you in the next session.